Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the double angle formulae. So these formulae, sine 2x equals 2 sine x cos x. So just very quickly, what this allows you to do is say, work out sine 60 degrees is 2 sine 30 times cos 30, or sine 40 degrees equals 2 sine 20 times cos 20, as long as you know sine 20 and cos 20. So they're clever little formulae. Cos 2x equals cos squared x minus sine squared x. Tan 2x equals 2 tan x over 1 minus tan squared x. Now we can prove these for these formulae that we worked out for sine, and later we'll show you for cos and tan, which we proved in a previous video. But we start with sine a plus b equals sine a cos b plus cos a sine b, and all we do is replace a and b by x. So we make a and b equal to x, which gives us sine x plus x. Sine 2x equals 2 lots of sine x cos x. And the same way, we start with cos a plus b equals cos a cos b minus sine a sine b, and then we equate a and b with x. We substitute x for a and b at once, and we get cos x plus x, which is cos 2x, equals cos squared x minus sine squared x. Isn't that beautiful? And the same way, tan a plus b equals tan a plus tan b over 1 minus tan a tan b. Substitute a and b as x. Tan 2x equals 2 tan x over 1 minus tan squared x. And as I say, we proved the three formula for sine a plus b, cos a plus b, and tan a plus b in a previous video, which I will put in the description. We can also prove the formula for sine 2x directly. Now we're using the Robertshaw proof. There were different proofs of, it's a long story. If you watch the videos, you'll see it all. There were different proofs of the formula for sine a plus b. We're using what's called the Robertshaw construction, which was suggested by one of my viewers, Andy Robertshaw. But basically start with this triangle. So the area PQR equals a half PQ times PR times sine 2x. PQ and PR we've set up as 1. So the area PQS is a half 1 times PS times sine x. PRS is a half times 1 times PS times sine x. The area of the big triangle is the sum of the areas of the small triangles. The area of the small triangles is a half, and then PS is, we can see, is cos x, because cos x equals PS over 1. So PS is cos x. And so if we substitute in for PQS, PRS, and PQS, if we substitute in for those areas, what we get is a half times 1 times 1 times sine 2x equals the stuff on the right, which means that a half sine 2x equals sine x cos x, and then multiply both sides by 2. It means sine 2x equals 2 sine x cos x. Yay, we proved it. Then we're going to prove that cos 2x equals cos squared x minus sine squared x by the cosine rule. And again, this is Andy Robertshaw's proof. So we start with the same triangle. Cosine rule says QR squared equals PQ squared plus PR squared minus 2PQ PR cos 2x. We then substitute QR for QS plus SR. Expand out that bracket. We subtract QS squared and SR squared from both sides, and then actually we add 2PQPR cos 2x to both sides, and then we take 2QSSR from both sides. Basically we just manipulate the expression above. We then realize, and this is kind of beautiful, that PQ squared minus QS squared is 1 by Pythagoras' theorem. PR squared minus SR squared is 1 also by Pythagoras' theorem. So we end up with 2 here. We divide through by 2 to give this. We then divide through by PQPR. We then realize that 1 over PQ is cos x. 1 over PR is also cos x. QS over PQ is sine, and SR over PR is sine x. So cos 2x equals cos squared x minus sine squared. So that's the direct proof, but actually we've already proved it once. We're addicted to proof. One more thing. You may well know sine squared x plus cos squared x equals 1. This is the trigonometric version of Pythagoras. It's directly provable from Pythagoras' theorem, but this is an important identity and one you'll use a lot. Sine squared x plus cos squared x is 1. We already know that cos 2x equals cos squared x minus sine squared x. So what we're going to do is, from the identity at the very top, sine squared x plus cos squared x is 1, it tells us that cos squared x is 1 minus sine squared x. So here we're going to put in this cos squared x as 1 minus sine squared x. That tells us that cos 2x equals 1 minus 2 sine squared x. It's an alternative way of expressing cos 2x. Also, sine squared x is 1 minus cos squared. Or put it another way, minus sine squared is cos squared minus 1. So what we can do is replace this minus sine squared here with cos squared minus 1, which tells us cos 2x equals 2 cos squared x minus 1. Yay, how interesting. Okay, I hope you enjoyed this. We enjoyed making it. So the point we're making here is there's 3 ways of expressing cos 2x. It's cos squared x minus sine squared x here. It's 1 minus 2 sine squared x here. And it's also 2 cos squared x minus 1 here. So there's 3 different ways of writing it. Hope you like this. We like making it. Please do, if you want to, subscribe and hit the notification bell. I'd love to hear your ideas. And most of all, I hope you enjoy your mathematics.